We are told at time t seconds, where t is greater than or equal to 0, a particle p moves so that its acceleration, a meters per second squared, is given by a equals 1 minus 40 I plus 3 minus t squared j. At the instant when t equals 0, the velocity of p is 36 I meters per second. Okay, we have been told for part A to find the velocity of p when t equals 4 for 3 marks. Okay, so I'm first going to highlight that t has to be greater than or equal to 0. I'm going to highlight the equation for the acceleration, and I'm going to highlight that when t equals 0, the velocity of p is 36I, because what this is, it is the initial condition. Okay, and what an initial condition is what is satisfied at t equals 0, or when the model begins. Okay, and then we have been asked to find the velocity of p when t equals 4. Okay, so the first thing I'm going to do is I'm actually going to use our equation for acceleration, and because we need to find the velocity, what we need to do is we need to integrate our equation for acceleration. So what we need to say is that the velocity v equals the integral of acceleration with respect to time. Okay, remember you need to underline v and a because they are your vectors. Okay, from here what we can say is this means v equals the integral of 1 minus 4t I, now underline I because it's a vector, plus 3 minus t squared j, underline that, and then with respect to time. Okay, the next thing we're going to do is we're going to split up our integral. Okay, and what this means is we will get, this becomes the integral, okay, of 1 minus 4t I, wrong way around, I, with respect to time, plus the integral of 3 minus t squared j with respect to time, like that. Okay, now we can proceed with integrating. So we will get this equals, so the integral of 1 with respect to t is going to be just t, and then the integral of minus 40 with respect to t is minus 4t squared over 2, which is minus 2t. Okay, so minus 2t and then squared. Okay, so we have that. We're going to close our brackets and we're going to put our I vector, and then we're going to add, so don't worry about the constant just yet because we're going to combine the two constants together, plus, and then 3 integrated with respect to time is 3t, and then minus t squared integrated with respect to time is minus t cubed over 3. So minus t cubed over 3. Put the j vector at the end, like that. And then we're going to add our constant of integration. Okay? So what we've been told is when t equals 0, the velocity of p is 36I. Okay, so what we can say is when t equals 0, v equals 36I. Like that. Okay, and from here we can say that 36I, so what I've done here is I've put in, so if actually we say this one is v, what I've done is I've put in 36I for v here, and then I'm going to plug in t equals 0 for each of our t's here. Okay, so what we'll end up is 36I equals 0 minus 2 times 0 squared I plus 3 times 0 minus 0 cubed over 3, like that, j plus c. Okay, what this means is c is just 36I. Okay, so we say therefore c equals 36I, like that. Okay, and the way you get this is because this 0, so you've got 0 minus 2 times 0, so that's 0 minus 0, so that's 0, so this whole thing is cancelled, and then 3 times 0 is 0, minus 0 is also 0, so that cancels. Okay, so now we've got 36I. What I'm going to do is I'm just going to rewrite our velocity equation. So v equals t minus 2t squared I plus, actually, what we'll do is we'll say, and then this is going to be plus 36, just like that, and then I. So what I've done is I've moved the 36I into the I component of our vector like this, right? And then plus 3t minus t cubed over 3, okay, j, like that. All right. Now, remember, we needed to find the velocity of the particle P at t equals 4. So the final step is just to plug 4 into our velocity equation. So what we can say is v 4. So this is like, you know, with functions, if you have, say, fx equals x squared minus 5, whatever you put into the x for fx, you put into the x squared minus 5. So that's exactly what we're doing here. So we're just going to do, this is 4 minus, so 2 times 4 squared is 32 plus 36. Okay, I plus, and then 12 minus, so 4 cubed is 64, so this is going to be 64 over 3j. And if you were to put this into your calculator, what you would end up with is 8i, underline your I, plus, minus 28 over 3j. Okay, and one thing you shouldn't forget to do here is include your unit. So we're going to say meters per second because that is unit of velocity, so speed. So this question is worth 3 marks. Your first mark comes from integrating a with respect to t to obtain your velocity. So that gets us from up to here. Your second mark comes from getting the correct velocity function with your constant. And your third mark comes from using the initial condition we've been given to find the value of your constant, plugging in t equals 4 to get the correct final answer. Part B has asked us to find the value of t at the instant when p is moving in a direction perpendicular to I for 3 marks, okay? When the question says moving perpendicular in a direction perpendicular to I, what this means is we are looking when there is no I component. And the reason you know that this is what you're looking for, so if I was to draw a quick sort of coordinate system, something like that, yeah? We have I here and we have j here, okay? If you're moving perpendicular to I, you are always going to be moving in a straight line away from I, okay? Because any other way, you're not moving perpendicular, because perpendicular means at a right angle, okay? So to always be moving in a perpendicular direction to an axis, you need to be moving away from it, or there is no change in that axis. So there is no change in the I, okay? So what we want to do is we want to look for when the I component of our velocity is 0, okay? And because the velocity is what is enabling us to move, okay? So you can't look at the position vector because having a position on its own doesn't allow you to move. It's having a velocity which allows you to move, okay? So you want to be looking at the velocity component, and what you want to do is you want to say when t minus 2t squared plus 36 equals 0, okay? What I'm going to do quickly is I'm going to rearrange to make this nicer. So I'm going to say this becomes 2t squared minus t minus 36. So all I've done is moved everything, so this equals 0. I've moved everything to the other side to bring the minus 2t squared term to be positive. And then from here, if you are to use your quadratic formula, okay, you would use a for 2, minus 1 for b, and minus 36 for c, and you would get 2 times, okay? You would get that t equals 4.5, and that t equals minus 4, okay? Now, remember, we were told in part A that t has to be greater than or equal to 0, and that makes sense because you can't have a negative time. So what you would say is that this one is less than 0, so like that, and you would say, therefore, it is invalid, like that, okay? And then you will conclude by saying, therefore, t equals 4.5, like that, okay? So this question is worth 3 marks. Your first 2 marks come from equating your I component of v to 0 to get t minus 2t squared plus 36 equals 0. So this line here gets you your first 2 marks. And then your third and final mark comes from getting that, solving the quadratic first, getting 2 solutions and ignoring the invalid one to leave t equals 4.5, okay? Part II says, at time t seconds, where t is greater than or equal to 0, a particle q moves so that its position vector r meters relative to a fixed origin O is given by r equals t squared minus t I plus 3tj. Find the value of t at the instant when the speed of q is 5 meters per second. Okay, so what I'm going to do is I'm going to highlight that t is greater than or equal to 0. I'm going to highlight the position vector equation, and I'm going to say that we need to find the value of t at the instant when the speed of q is 5 meters per second. And this is really important because the speed, okay, is the, so if you say speed, this isn't the same as velocity. Speed is the modulus of your velocity, okay, or the magnitude of your velocity. So what we need to do first to find anything to do with the speed is we need to solve for the velocity, okay? And from here, what we're going to do is we're going to use a rule that your velocity component, okay, because we're given the position vector, this is d by dt of your position vector component, like that, okay? So what we can say from here is that the velocity component equals d by dt of t squared minus t I, underline the I, plus 3tj, underline the j, like that, okay? What we can do here is we can split up our derivative. So what we can say is the velocity equals d by dt of t squared minus t, right, I, plus d by dt of 3tj, like that. Now what we can do is we can actually differentiate it. So we can say this equals, okay, the derivative of t squared is 2t. The derivative of minus t is minus 1. So that, and then I, plus, now let's do the j component. The derivative of 3t with respect to t is 3, okay? So plus 3j, like that, okay? So now we've got our velocity component, which is good, okay? So to find the magnitude of a vector, what you need to do is, if we say for a vector ai plus bj, like this, the magnitude, or the modulus as it's denoted, plus bj, like that, okay, equals the square root of a squared plus b squared, okay? So what we need to do is we need to find, or to find the speed, which is the magnitude of v, we need to find the square root of 2t minus 1 squared plus 3 squared, okay? So what we would end up with is speed equals the square root of 2t minus 1 squared plus 3 squared, and we know that the speed equals 5, okay, because that's what we've been told in the question, okay? From here, what we can do is we can square both sides, so we will end up with 2t minus 1 squared plus 3 squared equals 25. 2t minus 1 squared equals, so 25 minus 9, because 3 squared is 9, bringing it to the side is 16. 4t squared minus 4t plus 1 equals 16. Rearranging this, we would get 4t squared minus 4t, and then 1 minus 16 is minus 15, like this, which equals 0. Then if you were to use your quadratic formula, okay, and you were to plug in a value of a equals 4, b equals minus 4, and c equals minus 15, you would get a value of t equals 2.5 or t equals minus 1.5, okay? Again, because t has to be greater than or equal to 0, you would say that minus 1.5 is less than 0 and therefore invalid. And you would say that therefore t equals 2.5, like that. So this question is worth 6 marks. Your first mark comes from differentiating r with respect to t to get your velocity, okay? And so showing any sign of that will get you your first mark. Your second mark comes from getting the correct velocity, as we have here. Your third mark comes from using the magnitude to give an equation in t only. So as we have over here, your fourth mark comes from rearranging to get this line. Your fifth mark comes from solving the problem by solving for t. So setting up in a quadratic to try and solve for t, as we have here. And then your sixth mark comes from getting t equals 2.5 as your final answer.